last one, I don't know quite what question to call it, but it's the last page, and this one has some valuable information. So the average height of young adult males has a normal distribution with a standard deviation of 2.5 inches. That's kind of like coming from a population, right? Standard deviation. You want to estimate the mean height of students at your college or university to within 1 inch. So that's the margin of error we're looking for. We want a 93% confidence interval. How many male students must you measure? For this one, we have to go back to the formula. N is equal to, so we're going to have to get that formula. Remember, we had to solve for it. Let's see how much I can remember here. It was squared. The margin of error goes in the denominator. I remember that part. We had a z critical times the standard deviation. Okay. How do we get the z critical? Well, for 93%, what we need to do for a confidence interval of 93%, we can come back to distributions. You could look it up on the table, but a lot of tables might not have 93%. So we come to normal. We'll use a standard normal. And what we're going to do, we're looking for a confidence interval. So we want the middle between these two values. And we want 93% in the middle, so 0.93. And the z value that we get, the critical value is 1.812. Let's round it to, let's go to 4 decimal places, right? Why not? So this is going to be equal to, and since we're going to square it, you could take either the negative or the positive. It doesn't really matter. This is sort of the end boundary. 1, I'm going to go to 8119. Let's go with that. Times the standard deviation of 2.5 divided by the margin of error, and then we square it all. Okay. This is all from memory, so I hope it all works out. If not, I'll do a new video and you'll never know I did this one. Hey, we all get shy sometimes when we make mistakes, but I think this is pretty good. Oh, I almost made a mistake there. Squared. Everything is squared. Okay. So we're going to take this as 1.8119 times 2.5. Divided by the margin of error. I should have put that in there. It's going to be 1 inch, which is cool. It's not just E. It is. We know what E is. It's 1. I love dividing by 1. I actually didn't need to do anything, but we'll put it there, and then we'll just come out to the side. We can do x squared. It's going to square the whole thing, and we get that we need 21. And I'll just put this in as 21 people. But that's the level of, that's the number we're going to need to keep that margin of error down to 1 inch. Okay. Let's take a look at this last one. The American Community Survey, part of the United States Census Bureau, conducts a yearly census similar to one taken every 10 years, but with a smaller percentage of participants. Who cares, right? We could have started here and we'd be fine. The most recent survey estimates with 90% confidence that the mean households in the U.S. falls between these two values. Okay. Find the point estimate. That means what is the mean household income and the error bound for the mean U.S. household. Okay, so what is this saying is we want to find what's between these two numbers. So the way we do that, you take the two numbers, add them together, and then divide by 2. that will give us the middle point, which is our point estimate. It'll give us the mean. Because remember on here, what we're really doing is this is the interval, actually this, where this is our 90%, not that one there. So 69,720, 69,922. That's what a confidence interval is. We're looking for the mean in the middle. So let's go ahead and we've got our calculator going. 720, 20 plus 69,922. So order of operations, and then I'm going to divide it by 2 or put parentheses, whatever you. So 69,821. It goes here in the middle. So the point estimate is the mean for mean U.S. household income. I'll just do it as X bar because this is coming probably from a sample, right? A survey we're saying was 69,821. Kind of sloppy there. Rewrite that. And then what they want to find is the error bound. How much is the error? Well, it's how much goes from here to here or here to here. So we could subtract this mean of 69,821 from either one of these, and that gives us our boundary. So I'm going to take the 69,821. So that's my answer. I'm going to subtract the smaller number. You could subtract the bigger number, but then it would be negative, and you just use the other one. So 69,720. Use either one, and you'll see that it's got a bound of 101. So if you add 101 to this, you go up. Subtract 101, you go down 101. So plus or minus 101. That's pretty much basically all you got to do there. Okay. You'll see some of these questions in the homework. That's why I put this one in there. I wanted you to be able to see that. So you're given the confidence interval as we were here. This is our confidence interval. Finding the mean, you add together and divide by 2. And then to find the margin of error, you subtract that point estimate, the mean, from one of the two ends. Either one, doesn't matter, gives you that, and then take its absolute value. It doesn't matter whether it's, because you're going to add it and subtract it. So that should take us to the end. Thank you so much.